Hi, welcome to the final number patterns tutorial. Today's tutorial is titled Application of Sequences and Series. In terms of what you need to know to progress on with this tutorial, you need to be familiar with your grade 10 work on number patterns. You also need to have gone through the first 3 tutorials on number patterns. The only reason we have decided to include this tutorial was to give you a better idea of the real-life applications of number patterns. We're going to start this tutorial a little bit differently from how we normally do. I want you to have a go at the following exercise. Press pause on your DVD player, and when you return, we'll work through it together. The first one I gave you to do read, if the first, fourth and 10th terms of an arithmetic series form the first 3 terms of a geometric series, determine the sum of 8 terms of the arithmetic series if A is equal to 5. Let us look at that information carefully. We know that T1, T4 and T10 of the arithmetic is equal to T1, T2 and T3 of the geometric. The first, fourth and 10th terms of an arithmetic sequence is equal to the first 3 terms of a geometric. But we know for an arithmetic series that term 1 is equal to A, term 4 is equal to A plus 3D, 4 minus 1 times D, and term 10 is equal to A plus 9D. Remember, the standard form is Tn is equal to A plus n minus 1 times the difference, which means that term, for example, term 10 is equal to A plus 10 minus 1 times the difference, which is A plus 9D, which I have over there. Alright, and that's the first 3 terms of our geometric progression. Now remember, in a geometric progression we have a common ratio, which means that term 3 divided by term 2 has to be the same as term 2 divided by term 1, correct? That means that term 3, which is A plus 9D divided by A plus 3D, is equal to A plus 3D over A. Now I just need to cross multiply, which means that A squared plus 9AD is equal to, that's that times that to get rid of that denominator. To get rid of that denominator, it will become A squared plus 6AD plus 9D squared. That times that. A squareds on both sides cancel. 9AD minus 6AD is 3AD is equal to 9D squared. Divide through by a common 3D. That means that A is equal to 3D. That's equation 1. Now look at the other bit of information I gave you. I said that our first term is equal to 5. That means that A is equal to 5, which is equal to 3D. That means that D is equal to 5 over 3. That is our common difference for the arithmetic. And I've got my A value, which is 5. Now I'm looking for the sum of 8 terms. Sum of 8 terms, because it's arithmetic, we're going to use the formula Sn is equal to n over 2 multiplied by 2a plus n minus 1 times the difference of 5 over 3. Let's just erase all of this. that means that the sum of 8 terms is going to equal 8 over 2 is 4, 2 times 5 is 10, plus 8 minus 1 is 7, times 5 over 3 is going to give me 35 over 3. 10 is the same as 30 over 3, common denominator. That means that the sum of 8 terms is equal to 30 plus 35 is 65 over 3 multiplied by 4, which is going to equal 65 times 4, which is 260 over 3. If you want to simplify that further, you can. 260 divided by 3 is equal to 86.66 recurring, or just 86.7. That is the sum of 8 terms of this year. Number 2 says that the last 4 terms of a divergent geometric series add up to 210. The common ratio is 2, and our first term, our a value, is equal to 4. And we are looking for the last 4 terms. Now let's not worry about the last 4 terms just yet. Let us start by working out how many terms add up to 210. Sn is equal to a, which is 4, times r to the power n minus 1 over r minus 1, and that has to equal 210. That means that 2 to the power n minus 1 is equal to 210 divided by 4. The reason I'm not worrying about the denominator is because 2 minus 1 is 1. 210 divided by 4 is going to give me, I'm just going to leave it for now as 210 over 4. That means that 2 to the power n is equal to 210 over 4 plus 1 or plus 4 over 4, which is going to give me 214 over 4. Now if you have done logs, you are going to have to use logs to calculate n. If you haven't done logs, skip on to the next example. 2 to the power n is equal to 214 over 4. That means that n is equal to log base of 2, 214 over 4. That's going to give me, now 214 over 4, I can simplify it to be 53.5. Log of that is going to give me 5.74 terms. Now 5.74 terms, remember I said how many terms add up to 210 or more. 5.74 terms will add up to 210. That means that we are looking for n is equal to 6 terms. When n is equal to 6 terms, what is going to be the last 4 terms? Well, let's look at it. We can do this because it's only 6 terms. We can start off by saying 4 plus 8 plus 16 plus 32 plus 64 plus 128. That means that our last 4 terms are going to be 16, 32, 64 and 128. Number 3 says which term in the series 12 10 and 5 over 7, 9 and 3 over 7 will be the first negative number. So we are looking for an n value. We are looking for when Tn is the first negative number, so when Tn is less than 0. Now firstly, is this arithmetic or geometric? Initially, most of you would be inclined to say geometric. But let's look at this. They've got a common denominator of 7, sort of. So I'm going to convert this to all being over 7. 12 is the same as 84 over 7. 10 and 5 over 7 is the same as 75 over 7. 9 and 3 over 7 is the same as 66 over 7. Aha, now look at this. What's our common difference? This is actually arithmetic, because term 2, 75 over 7, minus term 1, 84 over 7, gives us a common difference of minus 9 over 7. That minus that will also give us minus 9 over 7. That means that this is arithmetic, with a being equal to 84 over 7 and difference being equal to negative 9 over 7. I'm looking for when the n value, when Tn is less than 0. Let's start by looking for the n value when Tn is equal to 0. Now remember that Tn is given by a plus n minus 1 times the difference, which in this case would be 84 over 7 plus n, which we don't know, minus 1 times the common difference of negative 9 over 7, but we are looking for when that is equal to 0. That means that n minus 1 multiplied by negative 9 over 7 is equal to negative 84 over 7. I just took that across, but I flipped it around. That means that n minus 1 on its own is equal to negative 84 over 7 multiplied by 7 over negative 9. All I did was take out that on that side. What I do to one side, I do to the other. That means that n minus 1 is equal to, those 7's cancel, negatives cancel. That means that we're left with 84 over 9. Take that 1 across, it becomes plus 1 or plus 9 over 9. That means that n is equal to 93 over 9, which is the same as 10.93 divided by 9 is 10.3 recurring. So the 10.3 term is equal to 0. We are looking for when n is less than, what value of n, which term is going to be the first negative. That means that n is going to equal 11. The 11th term is going to be the first negative, because the 10th term is still going to be positive. And let's work that out. In this case, T10 is going to equal a plus, a is 84 over 7, plus n minus 1, which is 9, times the difference of negative 9 over 7, which is going to be 84 over 7 minus 9 times 9 is 81 over 7, which is equal to positive 3. 84 minus 81 is positive 3 over 7. So the 10th term is positive 3 over 7. The 11th term, T11, is going to equal 84 over 7 plus 10 times the difference, 10 times that, which is negative 90 over 7. 84 minus 90 is negative 6 over 7. So the 11th term is the first negative term, and the 11th term is negative 6 over 7. The fourth term of a geometric progression, that means T4 of a geometric progression, is 64 greater than the third term. So T4 is equal to T3 plus 64. The sum of the first, the sum of the third and fourth terms is 144. That means that the sum of the third and fourth, T3 plus T4, is equal to 144. Determine the common ratio. Now this is all dealing with geometric, which means we are dealing with A's and R's. Term 4 is equal to term 3 plus 64. Term 3 plus term 4 is equal to 144. Let us break that up into notation. Term 4 is the same as A times R to the power 4 minus 1, which is 3, is equal to AR squared plus 64. And here we have AR squared plus AR cubed is equal to 144. This is a slightly tough one to do. What I'm going to do is I'm not going to use this here just yet. I might have to use it. But let's start by using this and getting some sort of simultaneous equations going. T4 is T3 plus 64, right? So wouldn't that one read T3 plus T4, which is T3 plus 64, is equal to 144. T3 plus T3 is 2 times term 3 plus 64 is equal to 144 minus 64. 144 minus 64 is the same as 140 minus 60, which is the same as 80. That means that 2 times term 3 is equal to 80. That means that term 3 is equal to 40. Term 3 is equal to 40. That means that term 4 is equal to 40 plus 64, which is 40 plus 64, which is equal to 104. Now, they asked us to determine the common ratio. Remember, our ratio is given by one term divided by its previous term, which in this case is going to be 104 divided by 40. You can simplify that. That will give you 52 over 20. Simplified again will give us 26 over 10. Simplified again can give us 13 over 5. 13 over 5 is our common ratio. That is the answer we are looking for. By the way, now that we have our common ratio, we can work out our A value, our first term value, and all we have to do is say 40 divided by 13 over 5 to get to term 2, divided by 13 over 5 again to get to term 1. but you don't need to do that. I only wanted the common ratio. The last one I gave you to do said that the sum to infinity of a geometric series is 56. The first term is 8. Find the common ratio. Now all I'm going to do there is put it into notation. Sum to infinity I know is equal to a over 1 minus r. That's the sum to infinity. We know that the first term is equal to 8. We also know that the sum to infinity is equal to 56. That means that our a value, which is 8 over 1 minus r, is equal to 56. That means that 8 is equal to 56 multiplied by 1 minus r. 8 is equal to 8 over 56 rather is equal to 1 minus r. Take the r across, positive r is equal to 1, or rather 56 over 56, that's 1 minus 8 over 56, which is going to give me an answer of 56 minus 8 is equal to 48 over 56. 48 over 56 can be simplified. 8 goes into 48 6 times. 8 goes into 56 7 times. And that is our answer. Our ratio is equal to 6 over 7. From the advanced number patterns and the real-life application of number patterns questions, the first one I gave you said that a bouncing ball is dropped from a table that is 1.5 meters high. Let's just draw that in. So the bouncing ball is dropped 1.5 meters high. It's going to hit the floor and bounce back up to 85% of its height, and it's going to continue in that fashion. Now let's look at the total distance this ball is going to cover. Firstly, it's going to go 1.5 meters down. It's then going to go up 1.5 meters times 85%. It's then going to go down that distance. It's then going to come up again to 85% of the new measure, down again, and then 85%, and it's going to continue in that fashion until it eventually stops bouncing. Now, let's look at the full path of the ball. Firstly, it's going to travel when it's bouncing. Let's look at when it's bouncing back up. It's bouncing back up a distance of 1.5 times 85%, or times 85 over 100. When it's bouncing back up the second time, it's going to be 1.5 times 85 over 100 times 85 over 100. So we can see very easily here that our a value is equal to that, and our r value is equal to 85 over 100. Why is it an r value? Because it's geometric. We're not losing a fixed amount, we're losing a percentage each time. Importantly though, we are looking for the total distance the ball covers. Now remember that it's bouncing down over there, down over there, down over there, down, 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 but it's also bouncing up. So we are looking for double. Now each of these, except for the first drop, is doubled. Notice something, there's a black and a red mark for each bounce, except the one coming down. and we are looking for the sum to infinity. So let's start by looking at s to infinity is equal to a, which is 1.5 times 85 over 100, divided by 1 minus r, which is going to be 100 over 100, which is 1 minus r of 85 over 100, which is going to equal 1.5 times 85% or times 85 over 100 is 1.275 divided by 100 minus 85 is equal to 15. So it's divided by 15 over 100, and that is going to give us an answer of 8.5 meters. That means that the ball is going to, the upward bounce is going to be 8.5 meters. So the sum to infinity of its upward bounce is equal to 8.5. is its upward bounce. Now remember, notice for every black there's a corresponding red apart from that black over there. 8.5 is the bounce upward. Multiply it by 2 to get our total distance covered in the bounces. 8.5 times 2 is going to equal 17 meters. That's the total distance the ball covered, but that's excluding this initial bounce of 1.5 meters. So we need to add that in. That will bring us to an answer of 18.5 meters. That is the total distance that the ball bounced from the time we let go of it at the top of the table. Number 2. On your 16th birthday, when you turned 16, you set aside 100 Rand into a savings account. When you turn 17, you put away 200 Rand. And on your 18th birthday, you put away 400 Rand into a savings account. If you carry on in the same fashion, how much would you be putting away on your 35th birthday? Now, what type of progression is this? 100, 200, 400? This is geometric. Our A value is equal to 100 and our ratio 200 divided by 100 is 2. 400 divided by 200 is 2. Now we are looking for the amount, the actual amount on your 35th birthday. Now if on your 16th birthday that counts as your first term, term 2 is when you're 17, term 3 is when you're 18, how many terms will take you to 35? All we are doing to get to that number from there is we are saying subtract 15. 16 minus 15 is 1, 17 minus 15 is 2, 18 minus 15 is 3. So 35 minus 15 is 20. We are looking for our 20th term. Tn of a geometric is equal to a times r to the power n minus 1. We are looking for T20, which is going to be 100 Rand multiplied by our ratio of 2 to the power 20 minus 1. 2 to the power 20 minus 1 is the same as 2 to the power 19 multiplied by 100 is equal to 52,428,800. Don't you all wish we could be doing this? by the time we hit 35. Number 4 says consider the series or the pattern 2, 4, 4, 6, 8, 8, 16. Determine the next two terms. Now if you look at this pattern over here, let's look carefully at what's happening. We got 2, 4, 4. This doesn't seem to form a pattern. But look at this. 2, 4, 8, 16 means the next one will have to be 32, skipping a number which is part of the other pattern. Now let's look at the other pattern. 4, 6, 8, 10. So my next two terms are 10 and 32. I then asked you to find for me the sum of 100 terms. Now there's a problem with that, because we have an arithmetic series in black and we've got a geometric series in red. What I'm going to have to do here is I'm going to have to find my geometric series separate from my arithmetic. Now if I'm looking for my sum of 100 terms, wouldn't it be the sum of the first 50 terms geometric plus the sum of the first 50 terms arithmetic? Sum of the first 50 terms geometric would be A, which is 2, multiplied by our ratio, which is 2. 4 divided by 2 is 2. 8 divided by 4 is 2. Our ratio is 2 to the power 50 minus 1 over 2 minus 1. To that we have to add the sum of 50 terms. Sn is equal to n over 2 multiplied by 2a plus n minus 1 times the common difference of 2. 2 minus 1 is 2, so that just leaves us with 2 multiplied by 2 to the power 50 minus 1 plus 50 over 2 is 25. 2 times 4 is 8 plus 50 minus 1 is 49. 49 multiplied by 2 is equal to 98. 2 to the power 50, I'm going to do this all on my calculator as I see it. It's going to be 2 open bracket 2 to the power 50, which is a huge number, minus 1 close bracket plus 25 open bracket 8 plus 98 close bracket, and that gives us a really big number of 2.25 times 10 to the power 15. That's 2.25 times 10 to the power 15. And that brings us to the end of number patterns. Before progressing on to any other sections of work, please go through the exercise that I left for you in the workbook.